Alright, and the final essay for English 4 is Lesson 6. And we're going to go down here. Um, there's a lot of things to teach you how to read what we're about to read. But let me just skip ahead to 6.5 and writing about complex scientific topics. So, the title of this essay is Ocean Acidification. See this? Ocean acidification. If you can see, the root word here is acid. So it's basically turning ocean water more acidic, which is harmful to marine life. You'll read these two scientific articles: Sea Change, Ocean Acidification Drives Oyster Farmers to Hawaii, and Overview of Greenhouse Gases. And there's also a chart called How Ocean Acidification Affects the West Coast. Those are your three things. I'm not going to read the whole thing here. I'm going to leave that up to you. But I will explain this chart. How ocean acidification affects the West Coast. Okay, so continental shelf, that means over here is dry land. This is where the people live. West Coast upwelling happens when wind blowing across the ocean surface pushes surface water away from the West Coast shore. So here's the wind. One is the wind. See that? It's pushing water away from the shore. Deep, cold water is drawn up to replace the wind-blown water. See, this water gets pushed out, so other water has to come in to fill that gap. Nature abhors a vacuum, so anytime there's an empty space, nature will fill it up with something else. So the wind pushes that warm water out, the cold water comes up from the bottom. Upwelling is what that's called. Upwelling draws the acidic water to the surface. Let's see here. Normally, where do I go? Let's stay here for a second. Here's the ocean. Deep ocean currents move acidic water towards the west coast like a conveyor belt. It is a continuous process that takes decades, which means the effects of CO2 absorbed in the ocean today will not be seen for at least 30 years. So the acidic water here was caused back in the 70s, 80s, and 90s. Normally, ocean water is supersaturated with calcium carbonate. Marine life has an easy time growing shells and skeletons. Pteropods, crabs, and oysters are, or I guess crabs and oysters are pteropods? I don't think they would be part of the same thing. Anyway, undersaturated. Acidic water has much lower levels of calcium carbonate, making it extremely hard to grow shells and skeletons. Most marine creatures will expend all their energy starving themselves to death in the process. So they've got an exoskeleton that is made of calcium carbonate, and they draw that calcium carbonate from the water and use it to make their exoskeletons. But if the water is too acidic, the acid breaks up that calcium carbonate, and oh, here we go. Over here, calcium. This is organized in an odd way, but here we go. Calcium carbonate is a basic building block for marine life. Calcium and carbonate, carbon and calcium come together. Calcium joins with a carbonate atom and forms calcium carbonate. The process repeats over and over, resulting in water supersaturated with calcium carbonate. And how acidic water prevents it. Carbonic acid releases a hydrogen ion and becomes a bicarbonate. Basically, it takes this molecule and shatters it, breaks it up in a way that it's no longer usable. Calcium has nothing to join with to make calcium carbonate. This process repeats over and over, resulting in water that is undersaturated with calcium carbonate. So it's sort of like how you've heard, you drink milk to make your bones strong because you get vitamin D from milk and vitamin D and calcium. I think there's calcium in milk too. And calcium come together to give you strong bones. They're suffering from a lack of milk, for lack of a better metaphor. So that's how to understand this graph. And you could quote any one of these little paragraphs and use that to explain what ocean acidification is. This is the process by which the ocean becomes more acidic. Overview of greenhouse gases. So why is there acid water in the ocean, it's because greenhouse gases like carbon dioxide, here you go, carbon dioxide is the primary greenhouse gas. It interacts with the ocean water on top and changes it to acidic water. That water sinks down, becomes this cold current, comes up to the shores, and it harms all the marine life. Here's U.S. carbon dioxide emissions by source. Let's see here. Transportation, electricity, and industry take up the biggest chunks. This is a simple pie chart. You should be able to grasp it. Let's see here. Emissions and trends. Okay, so now the basic idea is that you're going to read those three things, and here is the prompt. It explains the developing problem of ocean acidification and its impact on oysters. This one provides information about carbon dioxide. Explain the relationship. Yeah, here you go. You have to explain the relationship between human activities and ocean acidification. Then the impact of ocean acidification on oysters and oyster farmers. And then number 3, address how changing human behavior could affect oysters. So what is ocean acidification? Why is it human caused? What is it doing? And then how can we make it better? Those are the points you have to hit in this article. All right, and we'll be done with section 6.